Cross-Account Access Overview. Welcome to the most comprehensive guide on AWS Cross-Account Access. We're going to walk through every single step, every parameter, and every response you'll see when setting up cross-account IAM roles. Think of cross-account access like giving someone from another company a visitor badge that works in your building. The trust policy is like the security desk checking their credentials, and the permissions policy determines which floors and rooms they can access. Today we'll cover account A, the trusting account, creating roles that account B, the trusted account, can assume. I'll explain every single AWS CLI parameter, what it does, why we use it, and exactly what response you'll get back. We'll be using real account IDs throughout this demo, so you can follow along step by step. Understanding the architecture. Before we dive into commands, let's understand exactly what we're building. We have two AWS accounts that need to work together securely. Account A for production wants to allow specific users from account B to access certain resources, but with strict controls. The beauty of cross-account roles is that account B users don't need permanent credentials in account A. They use their own credentials to assume a temporary role, getting short-lived tokens. This is much more secure than creating permanent users in each account or sharing access keys. The credentials expire automatically, and you can track exactly who accessed what and when. We'll see exactly how the Security Token Service (STS) orchestrates this dance between accounts. Let's start by setting up our AWS CLI environment properly. This is crucial because we will be working with multiple accounts, and you need to be absolutely sure which account context you are operating in. The first command, AWS STS get caller identity, is your best friend when working with multiple accounts. It tells you exactly which credentials you are using right now. When you run this, you will get back three critical pieces of information: your user ID or role ID, your account number, and your ARN. This confirms you are working in the right account with the right permissions. The AWS configure list command shows you exactly which credential source is being used. Is it from your .aws credentials file, environment variables, or an IAM role? This is essential for troubleshooting. Creating the trust policy document. Now we're creating the heart of cross-account access, the trust policy. This JSON document is like a whitelist that says, these specific entities from these specific accounts are allowed to assume this role. I'm using a here document EOF syntax to create the JSON file cleanly. This approach is much better than trying to escape quotes on a command line. The principal ARN AWS IAM account B user devuser is very specific. It allows only the user named devuser from account B. You could also use ARN AWS IAM account B root to allow any user from that account, but that's less secure. The external ID condition is crucial for security. It prevents the confused deputy problem, where a malicious user might trick a service into performing actions on the wrong account. We are now creating the cross-account role. We are actually creating the IAM role using the trust policy we just defined. Let me break down every single parameter in this AWS IAM create role command. When this command succeeds, AWS returns a complete role object with the ARN creation date and the trust policy you just attached. The ARN is what you will use to reference this role from other accounts. If you get an error here, it is usually because 1. You do not have the IAM create role permission, 2. A role with that name already exists, or 3. There is a JSON syntax error in your trust policy. The role exists now, but it has no permissions yet. It is like creating an empty security badge. We will add permissions next. Adding permissions to the role. A role without permissions is useless. So now we're going to attach a permissions policy. I'm showing you two approaches, using an AWS managed policy and creating a custom policy. AWS managed policies like read-only access are maintained by AWS and automatically updated when new services are added. They're great for common use cases and follow AWS best practices. For custom policies, we use create policy first, then attach role policy. The custom policy I'm showing allows S3 access but only to buckets with dev in the name. This is the principle of least privilege in action. When you attach a policy, AWS doesn't return any output on success. Silence is golden here. You can verify the attachment worked by using getRole or list-attached-role policies. Next, we'll set up the trusted account by switching contexts to account B. This is where the user who will assume the cross-account role lives. The user in account B needs specific permissions to assume roles in other accounts. The STS, assume role permission, is what allows them to call the assume role API. The policy I'm showing allows assuming any role in account A, but you could be more restrictive and specify exact role ARNs. Notice the condition requiring an external ID. This must match what's in the trust policy. Creating the user and attaching this policy gives them the capability to assume cross-account roles, but they still need to be explicitly allowed by each role's trust policy. Now let's discuss the assume role process. This is the step where the user from account B actually assumes the role in account A. The AWS STS assume role command serves as the bridge between these accounts. The response to this command contains temporary credentials, an access key ID, a secret access key, and a session token. These credentials are valid only for the specified duration and grant only the permissions of the assumed role. The session name is crucial for auditing. It appears in all CloudTrail logs. Therefore, use meaningful names such as devuser deployment task followed by date rather than generic ones. If this step fails, check the following points. First, ensure the trust policy allows your user. Second, confirm the external ID matches. Third, verify you have the STS::assume role permission. Fourth, check that the role actually exists in the target account. Using the temporary credentials. Once you have the temporary credentials, you need to configure your AWS CLI to use them. There are several ways to do this, and I'll show you the most practical approaches. The export commands set environment variables that the AWS CLI automatically picks up. This is temporary. They only last for your current shell session. Alternatively, you can use AWS configure set to store the credentials in a named profile. This is more permanent and allows you to switch between multiple assumed roles easily. The AWS STS getCaller identity command now shows you're using the assumed role. Your ARN will show the role name and session name. This confirms the role assumption worked. Now any AWS CLI commands you run will use the permissions of the assumed role, not your original user permissions. Advanced Trust Policy Features. Let's explore advanced trust policy features that give you granular control over when and how roles can be assumed. Time-based conditions are incredibly powerful for temporary access scenarios. For example, you can create contractor roles that only work during specific time periods, or set up maintenance windows that only activate during scheduled maintenance times. MFA requirements are essential for privileged roles. The AWS multi-factor auth present condition ensures the user provided a second factor, and the AWS multi-factor auth age condition ensures it was recent. IP address restrictions are great for hybrid environments, where you want to ensure access only comes from your corporate network or specific VPNs. When you have multiple conditions, they all must be true and logic. Use multiple statements for OR logic. Automation and scripting. In real-world scenarios, you'll want to automate the role assumption process. Let me show you a practical script that handles the entire workflow. This script demonstrates several best practices: error handling, credential validation, and automatic session cleanup. The JQ tool is invaluable for parsing JSON responses from AWS CLI. The R flag outputs raw strings without quotes, making them suitable for shell variables. Always validate that the role assumption worked before proceeding with other operations. A simple AWS STS getCaller identity check can prevent confusing errors later. Consider adding logging to your automation scripts. Knowing when roles were assumed and by whom is crucial for security auditing. Monitoring and auditing. Cross-account access creates additional security considerations, making monitoring and auditing even more critical. CloudTrail logs every assume role call with details about who assumed what role, when, and from where. The source IP address field is particularly valuable for detecting anomalous access patterns. The AWS logs filter log events command lets you search CloudTrail logs programmatically. You can create automated alerts for unusual patterns, like role assumptions from unexpected IP addresses or outside business hours. Access Analyzer can help you identify unused cross-account access. For example, if a role hasn't been assumed in 90 days, it may be time to review whether it's still needed. Set up CloudWatch alarms for failed assume role attempts. Repeated failures might indicate an attack or a misconfiguration. Let's walk through the most common issues you'll encounter when troubleshooting cross-account access and how to debug them systematically. The first step in any troubleshooting is always to run AWS STS get caller identity to confirm which account and user you're currently operating as. Many issues stem from being in the wrong account context. The AWS IAM simulate principal policy command is incredibly valuable for testing permissions without actually performing actions. You can test whether a specific user can assume a specific role. CloudTrail is your forensic tool. Look for assume role events to see exactly what happened and why it failed. The error code and error message fields provide specific failure reasons. Remember that IAM is eventually consistent. If you just created a role or policy, wait a few seconds before testing. This catches many mysterious access denied errors. Security best practices. Cross-account access amplifies both the benefits and risks of your AWS security posture, so following best practices is crucial. External IDs are your first line of defense against confused deputy attacks. Always use them for third-party integrations and make them unique and unpredictable. Principle of least privilege is even more important in cross-account scenarios. Start with minimal permissions and add only what's needed. The read-only access policy is often sufficient for initial integrations. Consider using AWS Organizations SCP's service control policies to add guardrails around cross-account access. You can prevent certain roles from being created or assumed. Regular access reviews should include cross-account relationships. Use Access Analyzer findings to identify overly permissive trusts or unused access paths. Real-world implementation guide. Let's wrap up with a comprehensive implementation checklist that you can use in production environments. Start with a pilot implementation between non-production accounts to validate your approach. This lets you work out any kinks without risking production systems. Always have a rollback plan. Cross-account access can be removed quickly by updating trust policies, but make sure you understand the impact on dependent systems. Document your external IDs and session naming conventions. Future troubleshooting will be much easier if you have consistent, meaningful naming patterns. Consider implementing automated credential rotation for long-term cross-account relationships. While assumed role credentials are temporary, the base credentials used to assume them should be rotated regularly. Thank you for following this comprehensive guide. You now have all the tools and knowledge needed to implement secure, auditable cross-account access in AWS.